Welcome back to The Deep Seed. This is episode 4 of the Valdibella mini-series, and this week I'm talking to Eleonora Chiri. She's a soil microbiology expert, which is a topic I absolutely love, and she's amazing at explaining the complex life in the soil in a way that is clear and easy to understand, especially for people who are kind of new to these topics. We talk about the symbiosis between plants and soil microbes, about the importance of fungal networks for soil health, about the power of introducing animals onto crop rotations, and so much more. This episode was made in partnership with Soil Capital. I'm your host, Raphael, and this is the Deep Seed Podcast.
I'm Eleonora Chiri. I'm a soil microbiologist, and I am part of the scientific committee of the practical school of Agroecology of the Valle Bella Cooperative, which is this independent organization that promotes knowledge sharing among the agricultural community and also of people that are curious to know about how systems can work in this agroecology framework.
What's the one piece of information you wish every farmer knew about soil microbiology?
Well, I wish every farmer would know and understand that it needs soil microbiology. It needs life in soil. That the soil as such exists only thanks to the biological component. In fact, the English language helps us so much to distinguish between dirt and soil. So we have two words to mention this one element. And dirt is just like, when if you put a pile of dirt on your hand, it's this destructured soil. It has no structure or shape for itself. And then when you talk about soil, you think of this sort of mud cake, color-wise, very rich and fluffy soil. And that soil has structure because there is organic matter into it. And the organic matter comes because life, it's part of the soil system.
For someone who's not familiar with this concept, that there is a difference, that there's a soil that is alive, could you describe this ecosystem in the soil? Like, what makes it so special?
Yes, just imagine a community, like a small village, let's put it this way, with not many inhabitants, but just those that functionally have an important role. So if you take away the baker from a community where no one else could replace his place, then little by little the community crumbles. So we can imagine the biological community in soils as these microelements, these microorganisms that also, they're all needed because they all play a functional role. And on top of this, we can build with more organisms, which are a little larger and slightly larger and so on. And then we cover all the trophic network of soils that also brings life to the above surface of the soil. So then we can start embracing the larger animals, the herbivores, the humankind. So we should imagine the soil life community as the basis for the life on top of the soil.
I read in a book recently that there is a symbiosis that appeared over hundreds of millions of years of evolution on Earth between plants and soil microbiology, right? That they both function together in the benefit of each other. Could you maybe sort of describe this symbiosis?
Yes. So let's start from plants. Plants are a very, very unique or special type of organisms that live on our planet. They're different from all the other organisms. They are stable. They're fixed in one place. They don't have legs. Plants cannot run away from an environment which is unhealthy or not productive for them. So they need to create conditions to be happy in there. And this, it happens thanks to a very good living agreement with the microorganism in the soil. It's mainly fungi that works with plant in exchanging nutrients and having a reciprocal benefit out of it. And where fungi are present, bacteria comes as well. So we're talking still about the microorganisms, so part of life in the soil. And everyone has his role, And then only when they synchronize with each other, they can really cover the all nutrient cycles, and nutrients can move also from one plant to another. So it's a benefit that it doesn't stay local. It also travels along the fungi hyphae, the mycorrhizas, and so the nearby plants can benefit as well from what the plants before in the row it's doing well with the microorganisms.
What happens to this soil life? You describe this complex, diverse life where every organisms play a different role, and it's like a complex community. If you take out parts of the community, it starts to crumble. What happened over the last 70, 80 years with conventional agriculture, the use of mechanization, chemicals and all of that? What happens to that community in the soil?
So what happened basically is that we pushed this community dynamics to benefit just one part of the community, which is usually like the bacteria. They are amazing, they're fast-growing, they're pioneers. Those are the ones that we can find in the most remote, unlivable place on Earth. And this happened against the evolutions and the development of the fungi community in the soil. And so if we imagine a cake with a certain slice which is allocated for bacteria, and the rest of the pie it's allocated for fungi in a healthy soil ecosystem, we have to imagine this cake sort of be able to expanding and receding depending on the needs of the ecosystem. So in an early stage ecosystem, you need a lot of bacteria because they are those that are able to live from air as well. They are able to get food out of air, and they are those that establish early plants. And then you need to switch into a more established community. You need succession to happen. If we want plants to establish, tree to establish, we really have to move forward with this soil community as well. And by disturbing the soil with all, the soil, with tilling and like a conventional agriculture that comes and disturbs the soil surface and so on, what we do, we bring the ecosystem back to day zero each time. I want to plant something new, and I just go around with a till. I just go back in my succession. So bacteria will come, they establish, they will grow fast. Fungi will try to establish as well and create these highways of nutrients distributions that then they will be cut and disrupt again the next time I disturb soil, and I go back. So it's an ecosystem that doesn't grow, basically.
Okay, so to improve this ecosystem, we need to favor the growth of fungi communities and networks. What would you say are the key elements, the key farming practices that favor the growth of these communities?
First of all, and most important, is avoiding soil disturbance. Of course, in the ideal case, there's no soil disturbance, but we're dealing with farms that also have to keep making a living also in this transitional phase. So minimum disturbance practices can help tremendously not to disrupt this communication network that the fungi are able to establish in the soil. So there's plenty of ways that one could work in decompacting the soil by acting not just flipping around the all soil surface. So there are machines that allows you with hooks to go deep into the soil at about 30 centimeters of depth, or you can regulate this and just create some air, some space for the plants to establish their root without completely disrupting the surface. And this, with time, it helps the soil to accumulate more organic matter, because that's what happens with the living biomass. There's living biomass, there's dead biomass. We need fungi mainly that process this matter, and then more can stay in the soil. So the higher is the residence time of this soil organic matter in the soil, the better it is for it.
Okay. More specifically here at Valdibella, how have you been monitoring the health of the soils of the different farmers here? And have you seen an improvement in certain metrics or certain measurements?
So I wish I could give you an answer, but we're not there yet with the community of the farmers at Valdibella. There's also the main job of the school at the moment. It's really to deliver the message that these are very, very much needed approaches to soil health. And we're having success because we say, that the most difficult things to change is the mind of the farmer. And that's really where the change needs to happen. And so by creating these events of community and knowledge sharing, talking about these techniques of agroecological techniques, we start to get the interest of those that actually work the land. And the vision of the Valdibella and the school is those to have a pilot farm. And we want to put into practice all this knowledge sharing that we're having in just one farm so that we can start monitoring together with the students. And so coming back, every month, every season, we will all see the signs of regeneration.
I realized just now while I was editing the video that we're missing a crucial piece of information here. To recap, Valdibella is a farming cooperative located in Sicily, made up of about 40 different farmers, but also a whole range of other people like experts and scientists, but also people doing farm work, marketing, sales, hospitality, and so on. Together, as a cooperative, they decided to purchase a new farm that was going for sale because a local farmer is now retiring. They will manage the farm together and transition it from a conventional system to an organic and regenerative one. The really interesting part is that they will be using this farm as a pilot farm to teach agroecology and soil health to everyone within the cooperative. They'll be able to make a whole range of measurements and observations to create a T0 assessment, and then keep measuring and monitoring month after month, season after season, and year after year. I personally love it. Such a cool idea. So yeah, that was the piece of information that was missing. We can now go back to the conversation. What have been the most recent exciting discoveries in the world of soil science? Like if you were meeting with fellow colleagues, experts in soil science, what would you be discussing?
I think what is great, the greatest things of our generation, let's say, of these times, is the understanding of how systemic the approach is, how we should move away from just this reductionist approach of looking at the functional group in the soil and just describing down to the super refined detail of what they're doing and how they're doing, and put them into context. Put them into the context of soil dynamics, seriously. And there are tools that are now allows you to study, you do you can do this dry run on softwares on how the community could actually behave. But then the field researchers is actually looking at confirming and reproducing these results. And this is, I think, is the biggest understanding, this multidisciplinary approach, which is not just there's one chemist and one microbiologist and then a geochemist that work together, but it's what is common is the project, it is systemic approach.
And that's something that's I guess is great about this agroecology school here, is that you're bringing together experts from different fields with farmers, with students, with the whole community of people, and everyone is involved in the conversation. So I guess you're breaking down these silos and you're creating a more holistic discussion, right?
Yeah, absolutely. The managing complexity is what we have to do.
Yeah.
There's no other solutions. And the sooner we stop fighting this concept and embrace it, then it becomes a strength of the conversation. It's myself, this is my very personal experience. I've been an academic researcher for many years, and the missing bits over there was like this bridging in communication. Okay, we're studying soil ecosystems and see how healthy how they look like when they're healthy, and then we just keep telling each other this stuff to each other at conference, and where are the actors that then they put this stuff into practice, and how, most important, can we deliver this information? Like, where is the connection in language also? And so this is actually a very difficult but very exciting part of the conversation, like being able to put together in one room during a day around the table with fine food also everyone that plays in this ecosystem.
And so when you participate to these teaching events that include farmers as well, what is the information you bring that gets the most reaction from them? Positive, negative, like the one thing that sparks the most conversation and debate?
Wow. So we're very provocative on that. I guess my personal experience, it's like the introduction of animal in the farm system that grows, let's say, vegetables or fruits. It's strange, but it is the most provocative one, because in the last 50 years, the agricultural system completely detached from livestock management. And if we talk to our grandfathers, they tell us how they were moving the animal in like it was a symbiosis with the plant system. And now, with all the agriculture incentive, also with a lot of what comes for the CAP, the European policy for agriculture, there's a detachment of these two systems. Animals are not welcome on the land where we grow stuff anymore. And so we have to overcome the missing inputs of the systems with the external input into fertilizer. We're not even discussing now whether they're organic or not, but it's an external input that is needed. And in fact, pastures co-evolve with animals. So the grass just grows better if it's beaten, if it's been grazed on. And not just the hay, this works also for the plants that we're used to, and trees developed with animals, co-evolve with animals. So,
has there been examples here at Valdibella of farmers who integrated animals into their systems? And have you been able then to observe the positive changes in the landscape?
Yes. So it's start to become a thing again. For example, to have sheep grazing between the almond tree growth. The animals are a very powerful tool, though. So it can go bad or very good depending on how you manage them. So management is crucial. All you want to make sure that they graze the grass, right? They don't graze the leaves of your trees, or even going for fruits if that's the case. So there should be a very good plan done before, when you know what is the right time for you to bring the animals, in order not to damage your production of almonds in this case, but also to make sure that there's no overgraze on the land, or the animal impact, it doesn't turn into negative. You just want to keep it on a positive side. And there's just a few elements you have to keep into account, and then you have it. It's actually very easy to plan a properly manage grazing with the animals. And so now we're not there yet. We're not there where there is a calendar, let's say, that is followed, and there's not much pre-planning. But it's more an opportunistic grazing, but it happens relatively at the right times, just by instinct, observing what's happening on the land. And people are happier with the results rather than being sad, or no one complains about animal damage on the trees. That's more like of a urban legend, Or really, it depends on what time of the year you put them. And so it's actually a surprising, oh wow, that is actually working nice on the land. Grass grows taller, or it stays greener for longer before the dry period arrives. So people just start to perceive this change, even if there is not a proper planning and proper monitoring done. So imagine whether we would collect all this information in addition.
Yeah, so you really are already observing these positive changes. But could you give us the scientific explanation of why having these animals grazing that land leads to higher growth of grass, more density, and longer survival rates. Like all of these positive changes you see
Yeah.
and that you want for healthy ecosystems. Could you really try and give us that scientific explanation of what is happening
Yeah.
to the microbiology that
Yeah.
generates that? Let me just take a few seconds to tell you about the official partner of the Deep Seed podcast, because without them, none of this would be possible. Soil Capital. Soil Capital is a company that accelerates the transition to regenerative agriculture. Soil Capital is a company that accelerates the transition to regenerative agriculture by financially rewarding farmers who improve things like soil health and biodiversity.
I was saying animals are a very powerful tool. And pastures and all the savannas, all the grasslands co-evolve with animals. And if you imagine a savanna like this Serengeti sort of national park, for example, in Africa, you would see these animals on the land moving in blocks, right? Like they do not just, you would not see a buffalo or a gnu just running around by itself and just wandering and grazing a little bit of this and a little bit of that. No, they all pack, there's a pack, because they need to protect themselves from predation. That's how nature evolved. And it's this pack behavior that makes the animals so great for the land. Because now, if you imagine a grazing event, what happened is that you have a bunch of animals, whether it's sheep or cows, herbivores anyway, being in an area, feeling the predation pressure, which could be in Africa is a lion or wolves, but it can also be the human presence, just shepherding like good shepherd of the land, or electric fence. You just make sure that the animal stays in one spot. And that's what they do there. So they eat, everything is there. They do not select. So they do not overgraze some plants and they do not undergraze some other plants. They fertilize the place with their droppings and the urines, and basically, if they do a well job, when they've been moved to the next patch, you want to see a mess. The land needs to look like a mess. There's been trampling going on. There's been grazing, a lot of grazing. There's been all this dropping left in there, and what has been created like that is the perfect natural compost. The microbiology in the soil has all the nutrients. It has enough nitrogen, it has enough carbon, it has enough fresh material because of all the trampled grass that is kind of in contact with the soil. That means with the microorganisms. There is humidity because water arrives into the systems. There is also inoculation of new microorganisms because the herbivores in their saliva and in their mouth, they bring new microbial communities. So there is diversification going on. There is also seeding for the next raining event, because with their droppings, they do drop seeds of plants that maybe they were not in this place where they've been grazing before. So, and grasses that have been grazed, they receive this signal that they need to grow again. So what they ask a little bit of energy from the root system in order to put much more vegetable aerial mass, and so they grow, and then they grow faster from the vegetative part, and then if they have enough resting time, which is crucial in the animal management, they can again put some resources into the root systems. And so one plant which is grazed in the proper way has time to grow. Whereas if a plant is been overgrazed, that means we don't allow enough time to the plant to recover from the grazing event. This plant will ask too much from the root system, which will become smaller and smaller, and then eventually the plant will die. So that's why pastures looks like a very low in biodiversity, because this extensive continuous grazing are not good for the grassland. That's why we lose plant biodiversity, for example.
On the drive here to the farm, Massimiliano was telling me that he's growing a lot of this, I think the name in English is honeysuckle.
Honeysuckle.
And he told me it was one of the best plants to restore soil health, especially in an ecosystem where it's difficult to have animals here. Could you explain why?
Yes, the honeysuckle, it's a leguminous. So it's legumes plant, and their speciality is that they make an agreement with bacteria, which basically are able to trap nitrogen from the air, this bacteria, and this nitrogen cannot be used by the plant unless it's transformed into a different type of compounds. And so they live together. The bacteria have a cozy space in the root system of the honeysuckle's roots. And that's because they don't really like oxygen conditions. So oxygen is not welcome for these bacteria in order for them to transform the nitrogen into a compound that the plant can take nutrients out of it. So in this symbiotic agreement, the honeysuckle plant can have nitrogen. It's like a nitrogen fertilizer addition just by living together in this symbiosis with this bacteria. And therefore, it doesn't need much as an external input to grow. And the best thing, it's also that it's kind of when there is abundance, it's shared. So these benefits are not just taken by the plant, but also the surrounding soil community close to the root systems. It's more alive and more active. So it's kind of also an horizontal benefits that moves on the soil.
Fantastic. We're going to close on this. Thank you so much for your time and expertise. That was great.
My pleasure. Thank you for this opportunity to talk a little bit about soil life.
Pleasure. Thank you so much for listening to this episode until the end. If you enjoyed this conversation and you would like to support me and my work, you can do that in just 2 seconds by clicking on the subscribe button just down here. Thank you so much and see you next week.